Inequalities involving absolute value less than. When solving inequalities that involve absolute value, there are two cases to consider. There's always going to be two cases. I need you guys to pay attention. Right now, we're going to deal with less than and less than equal to. Are you with me? Yes? All right, so here we go. Absolute value inequalities. So this you may want to add in your notes. If the symbol in the original problem, in the original inequality, is greater or greater than equal to, we are going to treat it as an OR. An OR means when we graph it, it is a union, or it is everything from graph 1 and everything from graph 2 will be our solution. When the inequality is less than or less than equal to, we treat that as an AND, which is an intersection or what they have in common. So what I'm going to show you here in a few minutes is that all absolute value inequalities have two cases, case 1 and case 2. I'm also going to give you something that is not in your notes, which is absolute value equations. Absolute value equations. So let's take it nice and easy. Again, I highly recommend that you write this down. Okay, if it's greater than equal to, remember we exaggerated great or instead of ER, OR, which means a union. And if it's less than equal to, it's an AND, which is an intersection. Okay, so let's go ahead and take a look at a couple of things real quickly. Alrighty. Here we go. If I gave you the absolute value of x plus 5 equals 13. The absolute value of x plus 5 equals 13. So this is solving absolute value equations. We're going to start off here. So there are two cases. Case number 1. Remove the absolute value symbol, write, and solve. So case number 1 is always the easiest case to remember, whether we're solving an absolute value equation or an absolute value inequality. Remove the absolute value symbol, and this becomes x plus 5 equals 13. We know we want to solve for x, so we subtract 5 from each side, and what do we get? X equals 8. Okay, so that's case 1. In case 2, we remove the absolute value symbol, and we change the sign of the term after the equal sign. So in case 2, instead of it being x plus 5 equals 13, case 2 would be x plus 5 equals negative 13. Are you with me? Now we would subtract 5 from each side, and we get what? X equals negative 18. Okay, so now we're going to check our work. Let's go ahead back to the original problem and let's see what happens. 8 plus 5 is what, guys? And does the absolute value of 13 equal 13? So x equals 8 is a true solution. Let's plug in negative 18. Negative 18 plus 5 equals a negative, and the absolute value of negative 13 is 13. So our answer would be negative 18 and 8. Does anyone have a question on an absolute value equation? Yes?
Why does the negative 18 go first and the 8 go second?
This is not an ordered pair. This is just what we've been doing all year long. Most correct to write the smaller number first when you write your answer in set builder notation. If you wrote 8, -18, it would not be incorrect. Okay? Remember we've been doing that all year, guys? Yes? Okay, here we go. Let's do example number 1. So let's solve an absolute value inequality. And my first one I'm going to do here is going to be the absolute value of 3a plus 4 is less than 10. So let's remember, less than, and we exaggerated it last week, is going to be an and situation, which means it's what the graphs are going to have, what, guys? In common. Good job. What they're going to have in common. Okay, so this will be, let's make case 1. And let me give you some rules on case 1. I just want to erase this so I have plenty of room. So when solving an absolute value inequality, case 1, remove absolute value sign, write and solve as is. So this is going to be 3a plus 4 is less than 10. Are you with me? Yes? Then we're going to subtract 4 from each side, and we're going to get 3a is less than 6, and my final answer here when I divide each side by 3 will be a is less than 2. That's case 1. So on case 1, I don't care if it's an equal sign, a less than equal to sign, or a greater than equal sign. Case 1, remove the absolute value, write the problem like there was no absolute value symbol, and sign. The only changes come in case 2. To form case 2, remove the absolute value sign, flip inequality, and change the sign of the term. After the inequality symbol. So, there are 3 things you need to do in case 2. Number 1, remove the absolute value symbol. Number 2, flip the inequality symbol. And number 3, change the sign of the term. So here we go. Instead of it being 3a plus 4 is less than 10, it is going to be 3a plus 4, change the inequality. So instead of less than, it's what, guys? Greater than, and instead of 10, it becomes -10. Outstanding job. So now we want to solve for a, subtract 4 from each side, and we get 3a is greater than -14. Divide each side by 3, and you get a is greater than -14/3, or -4 2/3. So now we want to graph this. Are you with me? It's a lot of work we've done, and now we're ready to graph. So our first graph is a is less than 2. My second graph is a is greater than -4 2/3, and then I will have a solution. Question, yes?
So do we always have to do both cases?
Only if you want to get, yeah, you have to do both cases because it's a less than, so you have to graph. Your solution is the graph of the two, what they have in common. Okay? And that's why I'm spending all this time going over it. So here we have, let's make our number lines. Okay? So A is less than 2 is an open circle at 2 and everything going to the left. Are y'all with me? Yes. A is greater than negative 4 2/3. It's going to be approximately here is an open circle at negative 4 2/3 and everything to the right. And now we're ready to go ahead and put our boundaries in. So my boundaries are going to look something like this. So look at the graph now. Remember, when it's an intersection or what the two graphs have in common, if one has an open circle and the other one has a closed circle, your solution has to be opened. So based on that, who could tell me what my graph is going to look like? What kind of a circle should I make it negative 4 2/3, class? And what kind of a circle should I make at positive 2? And then I'm going to shade everything in between. Okay? Now my solution, when I write it in set builder notation, will be negative 4 2/3 is less than A is less than 2. Does that make sense? Okay, so one more time. The most important thing I can tell you is that when you are solving these compound inequalities or these absolute value inequalities, there are always two cases. Case 1, remove the absolute value symbol, rewrite and solve. Case 2, change the inequality symbol and change the sign of the term. Okay? So that is a less than. So let's try a really easy one together. Let's do this one. Okay, so the inequality is the absolute value of y is less than 3. Who could tell me, how would I write case number 1? What's case number 1? Anybody have it? Go. Y is less than 3. Who could tell me what case 2 is? What's case 2? Case 2, 2 changes. Thank you. There you go. You flip the sign and you change it. Okay, y is less than 3. Let's graph it. Y is greater than 3. Let's graph it, and let's graph our solution. 1 second, darling. I was catching it. Thank you. I appreciate it. This would be a great lecture to go home and to re-listen to, okay? And this is probably one where you're taking more notes than normal, but that's okay. Okay, make sure that if you didn't write everything down because you're an auditory learner, that you go back in and you fill your notes in. Y is less than 3 will be an open circle at 3 to the left. Y is greater than negative 3, an open circle at negative 3 to the right. And who can tell me what my solution looks like? Remember, there's going to be two answers, the graph and your set builder answer. What's the solution going to look like? Thank you.
An open circle on the negative 3.
And what kind of circle on 3?
Open.
You got it. And then what am I going to shade? Everything in between. Good job. And if I were to write it in set builder notation, it would be negative 3 is less than y is less than 3. Any questions? Yes?
How would you know if it's an and or did you just go off because they have different signs?
Okay, how do you know? Because you look at the original problem. The original problem is less than. So this is less than. That's how you know. You always look at the original problem. Okay, sweetheart? Okay, let's go to the second part of our lesson. Second part of our lesson is absolute value inequalities with the word or. I'm just going to do it up here. I think it's easier. Sorry, guys that are listening or watching. Okay, here we go. So, inequalities involving or. Absolute values, inequalities with or. So here we go. Let's use the example. So this goes for greater than or greater than equal to. Remember, it's going to be a union, kind of like a wedding. All of your stuff and all of your spouse's stuff. Now you got a whole lot of junk. So here we go. The absolute value of 2b plus 9 is greater than 5. Case 1. Case 1, every time, just remove the absolute value symbols, rewrite it, and solve. So who could tell me what to write? Who could tell me what to write? Anybody? Thank you. Okay, well, we have to write 2b plus 9 is greater than 5 before we solve it, okay? Then we're going to do what? Subtract 9 from each side. And you have 2b is greater than negative 4. Divide each side by 2. You were absolutely correct. I just wanted the original inequality. But that's fine. B is greater than negative 2. So good job there, taking it all the way for me. Case 2. Case 2 always has the changes. So the first thing you do is remove the absolute value symbol. You want to try it? Go ahead.
2b plus 9 is less than negative 5.
Good job. So you take the absolute value symbol away. You rewrite it. You flip the inequality symbol, and you change the sign of the term after the inequality. So 2b plus 9 is less than negative 5. Subtract 9 from each side, and you get 2b is less than negative 14. Divide each side by 2, and you get b is less than negative 7. Now we are ready to graph. Are you with me? Yes? All right. So b, sorry, let's keep this down here, is greater than negative 2. B is less than negative 7, and then my solution. So remember, whenever it's a great door, you are going to remember it's a wedding. So graph 1 answer plus graph 2 answer becomes your solution. Okay, B is greater than negative 2. What kind of a circle at negative 2, guys? Open to the right. B is less than negative 7. What kind of a circle, guys? Open circle at negative 7 to the left. I should have just stuck a negative 8 in there also, just so we had a little bit more. So now graph 1 and graph 2 get married. So my answer is going to be an open circle at negative 2 to the right, an open circle at negative 7 to the left. That's what the graph looks like. And my solution set could be, it doesn't matter which way you write it, B is less than negative 7, or B is greater than negative 2. I don't care if you wrote B is greater than negative 2 first, or B is less than negative 7. The order doesn't matter. However, I usually write it, I look at my solution, and I write my answer from left to right. So when it's a greater, an or situation, you are allowed to put the word or in your step builders. Okay? So this concludes our lesson. I'm going to let you guys do some homework problems with me, so to make sure you understand.